The macro task is going to allow me to string together all of the individual point cloud tasks so I can run them in one process. Once we've filtered out the low points that would cause anomalous pits in the minimum grid surface, we can go ahead and use the adaptive tin ground filter to create a seed surface. I've created a point cloud task called seed surface. For source points to the minimum grid, we only want to use last returns, in other words singles and last of manys, because we know that first of many and intermediate returns automatically are not part of the ground surface, so there's no point in even looking at them. As far as classification for the source points, we want to obviously eliminate the low point noise. And for this data set alone, because we've retained class 9 and 11, I'm going to eliminate those as well. Destination class will be class 2 ground. I've opened the advanced settings. I'm generating seed points, so I've selected that option. I'm going to use the default parameters that LP360 has calculated for the angular threshold and maximum distance. And in this case, I only want to run one iteration, which is classify only seed points. So I'm going to apply to save. I need to open my LAS file for writing. And now I can execute the point cloud task. Upon completion of the point cloud task, LP360 will automatically load two new shapefiles. One that defines the processing blocks that were used in the computation, and the other that defines the grid that was used for the seed surface. Now let's take a look at the seed points. I'm going to use my ground filter, display only the ground points. I'll force 100% resolution, and I'll make the point size larger so you'll be able to see it. There you see the ground points that were selected for the seed surface. If you look at this carefully, you'll note that there actually is 1 point assigned per grid cell. Of course, the point is going to be located wherever in that grid cell is the lowest point. Let's take a look at the seed surface as a tin. And here we see the very coarse surface that's going to be the initial point for our ground. Now let's create another version of the adaptive ground tin filter that densifies the ground surface. I'm going to simply copy my seed surface point cloud task, and I'll call this one densify ground. I want to just emphasize one more time that the selection of these criteria, the seed sample distance, the node insertion parameters, the number of iterations, these are all somewhat subjective, definitely project specific, and these are parameters that you would fine-tune when you are doing your evaluation of sample tiles before processing the entire project. For source points, I'm going to use only last returns that remain in class 1 unclassified. Destination class will still be class 2 ground. As far as the seed point selection, I'm going to select use existing destination points and augment. This means it's going to look at the existing points on class 2, which I already generated as seed points, and it's going to attempt to add additional points to the ground based on the node insertion parameters. I'm going to use just the default specified values, and in the interest of time, I'm going to perform 5 iterations. This particular point cloud task is quite processing intensive, so you'll notice that you're going to have to wait a while even for this small amount of data. This is one advantage to using the LP360 standalone version for these point cloud tasks, because it does make full use of the 64-bit Windows technology, whereas ArcMap is still limited to 32-bit. Here we have a look in tin view of the resulting ground surface. Notice that it certainly isn't perfect. We've got evidence of some places where buildings have been added in. We've got some artifacts that might look like a little bit of vegetation that's left in. So this is definitely a process where you need to do some experimentation and evaluation of the parameters to get the best result you can, although no parameters are likely to produce a perfect result. The purpose of this demo is really just to show you how to use the tools so that you can do some more experimenting on your own. I haven't said this explicitly yet, but maybe you've already realized that you can't simply go back and rerun one of these point cloud tasks or another without reinitializing the data back to its raw state. Each point cloud task builds upon the other. So in the case of the demo, I created copies of the data at each interim step. There's another way that you can do this, creating another point cloud task called a macro task. I can say add task, and I'm going to pick the task type macro, and I'm going to call this one demo 0520. And notice it executes an ordered collection of tasks. The macro task is going to allow me to string together all of the individual point cloud tasks so I can run them in one process. I simply need to add them in the appropriate order. So I'll click the Add button, Add Existing Task, and I'll start with my initialize. This basically puts the data back in its raw state. Then I will add the low points single point and the low points grouped points, and then my seed surface task, and finally my densify ground task. Within the macro task, I could go back and change the parameters for any of these individual point cloud tasks so that I can rerun this over and over again on different test areas until I've got a final set of parameters that I'm happy with. As I mentioned in the content lecture, you're going to have to make some decisions about how either conservative or aggressive you want to be in terms of creating this initial ground surface. Either way, you're likely going to have to do some manual editing, either removing things that should not be in the ground surface or adding back in some features of the ground surface, such as hilltops, that were mistaken for non-ground features. Because the point cloud tasks do take quite a while to run, you might also want to consider not running it on the entire tile every time, but selecting some smaller areas using the various selection tools on the point cloud tasks toolbar.